So let's get started with the second part of the tutorial. And the goal now is to first install Kollaps and Thunderstorm, see how it works. It's actually, the process is rather easy, but we will go over it in detail. Then we are going to run a very simple experiment where we have a Hyperv3 server and a Hyperv3 client. Hyperv3 is a very well-known set of tools to measure the network performance, usually latency and bandwidth. And this is exactly what we are going to do. We are going to deploy a very simple topology with one server, one client, measure the bandwidth, and also measure the ping. So let's get started. I have a fresh machine, okay, nothing installed here. I am running Linux version 18.04, so Bionic, but in fact, any recent distribution should work without issues. And the other assumption is to have Docker and Docker Swarm running, and this is also the case. Okay, so I have already installed Docker in this machine, so I will run a simple hello world example just to make sure that my Docker installation is working properly. And as you can see, everything is fine. So the next step is to install Kollaps itself. And for this, and you can also follow the tutorial like this, I'm going to follow the instructions that are on the official GitHub page, okay? And we will follow the tutorial, and I will add things and comments as needed. So the first step, of course, is to clone the repository. So I'm going to pick this command. It's important to recurse submodules because we have some dependencies which are not on this repository, but which are important. So I am going to run this. It's not going to take much. And essentially, this allows you to build a Kollaps from scratch, to modify it, and so on and so forth. Okay. We have now two options. We could build some images that we already provide, and this is the step we are going to cover because it's easier and we don't need to change Kollaps for the purpose of our tutorial. But if you want, you can also build everything from source, which takes a while, but allows you to do any change you deem necessary. So let's move on and build first Kollaps. So I'm going to move to the Kollaps directory, and here I'm going to execute this command that allows me to build the Docker images. So while this builds, what is happening under the hood is that we essentially are building the emulation manager and the emulation core and the set of internal components. And next, so this is the key component that is going to be deployed alongside every container in the system. And the next step would be to build and deploy the deployment generator, which takes the topology and generates this. So while these builds, we are going to verify if our Docker Swarm is installed properly. So for this, I'm going to create a new window here. So I'm using screen, and I'm going to the tutorial and check the instructions for Docker Swarm. And this is also really easy to do. So I just have to make sure that Docker Swarm is initialized. And I'm going to get an error, as you can see here. And the reason for this is that I have two network interfaces. So I will need to pick one where Docker Swarm is going to listen to. So this is really easy. I just have to pick one. And in my particular deployment, I know that the right interface is this one. So at this point, this node is in a swarm. For the purposes of this example, we are going to use one machine, but if I wanted to use other machines, I would have to repeat this process for all the other machines, install Kollaps there, and then make sure that all the other nodes join the swarm as well. Next step is to create a network, and this network is a Docker network where all the processes will work on. And for this purpose, I'm going to create a Docker overlay network following this command. Essentially, I'm going to use the overlay driver, but you can use some other drivers such as IPVLAN and MacVLAN. The best one depends on your particular settings. And for this particular scenario, I'm going to say that my network is going to be called Kollaps network. So the network is created. Now let's move back to the compilation process. And the system is properly built. Okay, so now if I check the images, I should see there that I have the Hello World image that I have tested before. I have a base image, which is the one upon which Kollaps builds, and I have the Kollaps image itself. So in terms of setting up Docker Swarm, this is it. So this is done. Let's get back to the installation of Kollaps itself. And I'm now going to deploy or to build the deployment generator, which is, if you recall correctly, this tool here that allows me to pick the input topology and deploy this on containers. So let's run this. Okay, so after speeding this up, the deployment generator is built. So at this point in time, I have built the Kollaps core, which contains the emulation manager, the emulation core, and other tools. And I have also built the deployment generator. And we can see that both of these images have been properly built. So now that the tools are built, next step is to try out some applications. And for this, we are going to test out some applications that we have here in GitHub. And in particular, we are going to evaluate a very simple hyperv3 application. And this is our target topology. So I will have 3 hyperv3 clients, client 1, client 2, and client 3, one switch, another switch, and a server. And the links have these different properties, and we will see later why we have this particular configuration. So to do this, we already provide an example on how to do this, and we can, for this, we can navigate to the examples folder. And as you can see, we have the hyperv example, memcached example, and also Redis example. So you can try also these two out if you are interested. Let's move to the hyperv3 example, which is the one we are interested in. And here we have 3 different things. We have the file that describes the topology, so topology.xml, and this file is essentially puts into a precise description the topology that we have here. And we also have 2 different images. So this hyperv3 server is the Docker image for the server, and the hyperv3 client is the Docker image for the client. So let's look first at the topology file. So the topology file is a regular XML file. As you can see, we have lots of comments, which you can also study later. Right now, we are going to focus only on the most important parts. So first, we have the dashboard file, or sorry, dashboard service, which essentially identifies which is named dashboard, and specifies the image Kollaps / that dashboard, And this dashboard runs on port 8088 and is defined as a supervisor. So this means that this service has special permission and is able to monitor all the other services that are running on the experiment. This dashboard corresponds in our architecture to this component, which is essentially a very simple web-based interface that allows us to interact with the experiment, so start the experiment and stop the experiment, and also see some simple statistics about the usage of flows, bandwidth, and so on. So getting back to our description file, here on this part, we have the three clients. So I have the service, one service named client 1, another service named client 2, and yet another server named client 3. And these three services are using the same image, which is called Kollaps Hyperv3 client 1.0. So this image is the one that we will look in a few moments, but the essential is this image that we have defined here, okay? And this is a Docker image, and it can be anything you want. So if you want to evaluate your application, it's under this topology. It's simply a matter of updating the name of the Docker image to point to your image itself, okay? Additionally, we have this command tag, which specifies that this image is going to receive as parameter this server name, okay? And all of them receive this, and we will see in a second why this is useful. Next, I define the service of the server, so exactly the same as before. I have to give it a name, and I name it server, and I have to make it point to a valid Docker image, and this image in particular is Kollaps/Hyperv3 server, which, as you might have guessed, corresponds to the server image I have defined here, and which we will look into in a few seconds. The Hyperv3 server is named server, and this means that when the system is running, this container will obviously have an IP, and the server name will point to this IP. So this is the reason why we pass the command, why we pass the server name to command, because this allows at runtime clients to resolve the name of the server and connect to it. So this defines all the services that exist. So typically, this is where we define the set of images I want to consider. And here, in this bridges section, I'm going to define the network elements of the system, such as routers, switches, and so on. So I have two switches here, which correspond to switch 1 and switch 2 in my topology. Next step is to define the links. And for this, I need to define the links between every element in the systems. So, and I start by defining the link from client 1 to switch S1, which, if you recall, it's this link here, has a bandwidth of 100 megabits per second and a latency of 10 milliseconds. So, and the way I define this is very simple. So I say that my origin is the client 1, the destination is switch 1, there is a latency of 10 units. If you don't specify the unit, by default, we assume it is milliseconds, and there is an upload bandwidth and a download bandwidth of 100 megabits per second. And the network I am running this system on is the Kollaps network. And this is the network that, if you recall, we defined it and we created previously here. Okay, so previously we created the Kollaps network with the overlay driver, and in this parameter essentially says that these containers are going to run in this network. And this allows you to have multiple networks at the same time and multiple experiments and so on and so forth. Next, I need to do the same for client 2 to the switch S1, client 3 to switch S1, the link from switch 1 to switch 2, which, if you recall, is a 50 megabits per second link with a latency of 10 milliseconds. So this is essentially what I say here. A link from S1 to S2 has a latency of 10 units. I don't specify it, so this is milliseconds. And the upload and download bandwidth of 50 megabits per second. And it's also running on the Kollaps network. So it's important to notice that because I don't specify the reverse link, so I don't specify the link S2 to S1, the link is assumed to be symmetric. But if I wanted to have a different configuration, I could just duplicate this. So I could go to this link, S1, duplicate it and say that the link from S1 to S2 has these properties and the link to S2 to S1 has some different properties. So my upload bandwidth is 25 and not 50 in the other direction. And this would create a bidirectional link. But let's follow the experiment. So I'm going to remove this out. And finally, I need to define the link between the second switch and the server, which, if you recall, is a 100 megabits per second link with a latency of 5 milliseconds. So for simplicity here, we do not specify jitter or packet loss, but this could also be specified using these properties to fully specify what is expected of a link. So at this point in time, when I finish defining this section, my topology is defined and my images are defined, so the experiment is ready to run. But I want to go a step further and I want to make the experiment fully automated, so I want the clients and the server to start at some point, and I want to stop the experiment also at some point. So how does this work? So I can specify this in a dynamic section where I have where I need to schedule the events for clients and servers. So here I'm saying in this line, I'm scheduling an event for client 1 at time 0. So this is the beginning of the system. And I am saying my client must join the system at time 0. So as soon as the system starts, the client starts. And this is the same for client 2 and client 3. Now for the server, what I am doing is the following. I am defining a server, and at time 0, I'm saying join. So initially the system starts also a server, but there is an important detail here. I'm specifying an amount of 3. So what does this mean? This means that rather than starting only a single server, essentially I am saying that I want 3 servers rather than 1. So this is really a simple example of the expressiveness of the language. Then so when the experiment starts, all the services, namely the 3 clients and the 3 servers start, they run for 120 seconds, and then the 3 clients crash, so they are terminated abruptly, and the server leaves, which means the container is terminated gracefully. And I am terminating all the 3 containers. So this concludes the definition of the topology and the dynamics, and now the next step is to look at the images themselves before starting the experiment. But this is a good time now to take some questions.